All right, welcome, good morning, Melvin, Klaus. Thank you all for joining us. Really appreciate all of you being here. Hope your travel was smooth and that you're not too jet lagged this morning. I'm Ariel BenYishay. I'm the chief economist at our AidData research lab at William & Mary. I have to get some legalese out of the way. I have to tell you that you're being recorded. So your presence at the GeoField convening events grant permission to AidData, Dev Global, Mercy Corps, and partners to photograph and or video record your image and or voice. Permission is granted for us to release, publish, broadcast, or quote this material in public information programs and activities. Content procured may be included in future speeches or the internet through multiple broadcast channels and print media. Use of content, image, audio, or ideas will not be used for commercial purposes. Okay, we're through with that. Welcome properly. This morning, we're gonna just have some brief remarks from David Laborde, from our FAO hosts, Karen Macours, and myself. And then I'll also walk you through the agenda for the rest of the few days. So again, welcome, David. The floor is yours.
Thank you. Good morning, everyone. So it's a pleasure to welcome you this morning in this red room of FAO on what starts to become a little warm early summer in Rome. And I have the pleasure to have this convening here, knowing that actually 2.5 years ago, in the fall of 2023, we had the first very successful, I think, meeting here. And today I start to see a continuation of things that were discussed at the time, and also the results of research ideas that have emerged and now are starting to get publication, but also projects on the field. Now, what I want to raise is, if I look back and if I think how the world have changed, the first thing that is very relevant for us is the world is struggling to pay for data. And a lot of the surveys we have on the ground stopped to be funded. And it's not clear how much will be even funded in the next 2 years. So finding a way to still generate high quality evidence in a cost-effective manner, and in particular using remote sensing, is even more important today than 2 or 3 years ago. And I cannot emphasize this issue, okay? Most of the data, especially in some low-income countries we were used to operate with, may not be collected in the future. Some donors also will start to say, we have enough evidence, let's move and deliver more results on the ground. But I think, as you know, that now we don't have evidence on everything we want to do. And at the same time, if we don't deliver high quality research, you will see in 2 years ago, people saying, okay, we have spent money without results. And so it's going to be another reason to stop spending money, not just on collecting data, but on a number of development projects. So, just to say that what we do here is important, not just in terms of getting nice papers and nice research, but I think is essential in the theory of change we have in the world of today about development. Now, the good news is that actually the cost of collecting this data, of processing this data, the technology we have access to today is significantly better than what we had 3 years ago. And this is going to continue to improve. Something else that was touched 3 years ago is actually remote sensing data is also very important when, for safety reasons, we cannot operate on the ground. And here also, unfortunately, we have seen more extreme conflicts around the world, including in regions that were already highly vulnerable. And tracking what is happening, but also finding about how, in the context of crisis, we can deploy the right type of intervention with the right targeting, and we can really tailor our solution to the need, is pretty important. Now, I think that during the next 2 days, you are going to talk about a lot of why it's also difficult to do this, you know? What do we really observe? What is the level of confidence? How much noise we are dealing with? Are we too optimistic about actually some of the AI tool can really deliver? Can we really get control group? But this is going to be the part of the science that on all sides we can handle. The last point that I think was clear during the last meeting is also the remote sensing solution is great really to track what is happening to the project after the project starts to be funded and on which we still need to show results. Because this is also a significant problem in what we do. Donors expect to see outcome in 2 years, in 1 year, want to get results and impact in this time frame. And can be okay to pay for data during this time frame. But if we are serious about a lot of the challenges we are dealing with, they are not solved in 2 years. You don't restore carbon in soil in 2 years. You don't really know if your irrigation project works until you have enough good and bad years to see if it was really a good idea. And therefore, you know, this idea of building this continuity in the way we assess the project is also, I think, highly relevant. And that's where the cost aspect is important. And that's where also providing public good in this is important. Now, the good thing is that we are welcoming you at FAO is that we are already using some of this tool to support a project. So at FAO, you have this great combination of people doing research, and you will have a number of colleagues of FAO joining during the 2 days from my division, ESA, the Agri-Food Economics and Policy Division, from other parts of the organization, people working on geospatial data, people working on impact evaluation. But at FAO, we do research, we produce public good, but also we implement projects. So that's where really we can create these synergies and start to, in some time, also fix projects based on the knowledge that starts to be generated. So on one hand, you know, from a pure research point of view, you can say, I want to observe the world and not modify what I am studying. That's a very good principle, I like it. But in the real world, this is not something we can allow ourselves to do. First, for ethical reasons, both because we are using taxpayer money. So if we start to see that taxpayer money is not well used, we have to correct it. And then also because it's a livelihood of people. And sometimes people that are in life-threatening condition. But, you know, correcting the trajectory of the ship at the same time that we use this modern GPS for policy making is not something bad. It's something that we have to take into account in the way that we are working on that. And I think during the next couple of days, you will see a number of examples of this. In Somalia, in Ethiopia, in Niger, where we continue to implement this type of tool. So, like last time, I will say I hope that after these 2 days, the research agenda will be built and reinforced. A number of new ideas will be developed, and maybe more important, a new wave of collaboration because this is a field where actually we need to combine different disciplines. We also need to combine different organizations, in particular in a situation where resources are becoming scarcer and scarcer. And I'm not just talking about water, but also about money here. So now I give you the floor to my colleagues.
Good morning, everybody. I think my computer is too big for this thing. There we are. It's great to be here. Thanks, Val, for hosting. Thanks, Ariel, and the whole team for the invitation. I'm Karen Macours. Some of you know me on many different hats, so let me specify why I'm here. Some of you know me from CG, Times, and SPIA, etc. Some of you know me as just a professor at the Paris School of Economics or a researcher at BenYishay. I also am the editor-in-chief of the JDE, and together with Ariel, we co-edited the special issue on Earth observation and kind of impact evaluation in agriculture-related issues that many of you contributed to. So some of you do know me in that role, and I was very happy to engage with many of you in that process. And we're also very happy to announce that the special issue is now wrapped up. Kunmar, who is sitting here, sorry I hadn't seen you before, and Kunmar also co-edited this with us, and will be coming out, and I think provides a very nice example of what David was talking about, kind of the upcoming research in this field, but also, you know, the challenges that this research faces, kind of the next the steps forwards, etc. So in that light, I'm going to kind of just share some kind of broad kind of thoughts on where I see things are going, but also, you know, since I may as well be useful, and if some of you still want to publish in the JD, you want to hear how I'm thinking about this, so I'll share some of those thoughts in case that's helpful. Maybe a step back first in terms of why, when Ariel proposed this idea for the special issue, Andrew Foster, who was still the editor-in-chief and together with me, and who was at that point the source editor-in-chief, immediately said, yes, this is a good idea. This is a good idea, and I agreed. And why is because, you know, of course, in development economics, there is a very large history of work on the role of agriculture in economic development, on the, you know, and you know, why is there a large history of this literature is because agricultural growth and agricultural productivity has played an important role, and an historic role in economic development, and continues to do so, and continues to have an important role in food security you know, going forward. The reason why there is such a big literature in a certain way is because it's been hard to make progress both on the ground and in many different areas. While there has been productivity growth in many places, in other places productivity growth is less or is going backwards. There's a lot of market imperfections, a lot of reasons why kind of easy solutions don't necessarily always work. And so the literature tries to identify those market imperfections and then to evaluate policies or technologies, going back to my CGR days, to help address them. So we have kind of a literature looking at those questions, and that literature, the related literature is the literature, of course, looking at trade-offs between kind of environmental land use and agricultural productivity, so the environmental protection and ag productivity growth. With environmental degradation, with climate change, there is new challenges both on the ground and to the literature. And I mean, they're not new anymore, unfortunately. This has been going on for quite a while now, but I don't think we found the solutions to neither project-wise nor literature-wise. And so why is that? Well, there's challenges in this literature that there's many challenges. So some of those Earth observation can help address, others don't, but let me kind of flag kind of what when I get a paper at JDE, what are the challenges I'm looking at when it's a paper related to agricultural economic development broadly defined. Well, first of all, there is going to, like many topics, there is going to be, when it's kind of primary data collection with farmers or with other actors in the rural space, that usually is self-reported data, which comes with reporting bias, especially if, we just did an extension program to advocate for a certain practice, and then we go ask and whether farmers are using that practice. Well, they may just say, yes, of course we are doing that. There is also huge issues with not just report bias, but noise in measurements of productivity, so much so that to a certain extent, a bunch of papers don't even try to measure it anymore and stop at measuring practices. A lot of the kind of primary data collection is, apart from being expensive, and I will come back to this in a second, is short-term by nature. David mentioned this. That's partly because that's where the funding is, but a lot of the questions we're interested in are dynamic, are state-dependent, you mentioned that too, and that's in particular true for these for the challenges for which we don't really have yet good solutions: climate adaptation, adaptation to weather vulnerabilities, and environmental degradation more broadly. Obviously, there is program placement bias, and there is questions about, which is related to that, questions around scale. The scale of the problem that you guys are studying is massive. Is kind of, it's a global problem, and we need solutions at large scale. A lot of the literature with primary data collection only will survey data only, kind of almost by definition, is going to be limited in geographical scope. And as was hinted at, sometimes we can't actually go to the places, we can't collect survey data in the places where we need the most evidence, whether that's because of conflict or other access problems. I can go on. There is an interest in historic events, and of course, methodologically, spatial and intertemporal spillovers have plagued this literature for a long time. And people have been trying to find solutions. A potential solution is the integration of Earth observation that I guess I'm preaching to the choir here. You wouldn't be sitting in this room if you didn't believe that was the case. And so I'll be quick because I don't think you need a reminder, but going back to some of the challenges, observed measures as opposed to self-reported measures, both for productivity and for practices, longer-term follow-ups, high-frequency data, evidence, and this is kind of demonstrated in the special issue of you being able to use Earth observation to demonstrate the impact, if you want to, of new threats. So kind of there's papers, for instance, on gas flaring that will be presented or on the pollution of mines that we otherwise, with our usual data wouldn't be able to get to as well. And then kind of also an exciting part of this again that we show that is showcased, I guess, in the special issue is kind of using Earth observation data for the design of policy as opposed to just the evaluation or the observation on policy. Okay. The part that I wanted to kind of go a little bit slower on is kind of the challenges that I see in this literature and that we've engaged with the authors of the special issue in trying to address some of them and acknowledge other ones of them. And again, a lot of this is not going to be new, but so let me just kind of tell you what I see as some of the challenges. First of all, obviously, no data is perfect, and Earth observation data also is noisy, also has measurement problems, and also has biases. They're different biases, and they're different sources of measurement error, but they're there. And so that's kind of points to the need for ground truthing and for validation one way or the other, and creative ways of validation and of ground truthing, I guess, is part of that. The second challenge, and maybe that's a little bit less obvious to some of you in the room, is that pre-trends, evidence of pre-trends, evidence of you have high frequency data, you can look before things happened, you can look after things happened, you can do your fancy stagger diff and diff using the 500 different methods that people have established for this now. All very exciting. Well, those pre-trends don't substitute for a narrative defense of the common trend assumption. and never will. And somehow there is a kind of a huge misconception about this, where people think that if I can show my nice event study graph and I show that nothing was happening before the shock happened, then I have, and in fact, some of the feedback that some of you have gotten in the editorial process is like, no, you have not shown that there is that you can prove the common trend assumption. You can kind of show evidence that is consistent with your assumption. You still need to make a narrative case about why, after the shock happened, the trends would have occurred in parallel, would have stayed parallel if it wasn't for the intervention that you're studying or the shock you're studying. And so what that means is you need to know the reality of the problem you're studying on the ground. And some of the best evidence, of course, that we get from that is from people who know the reality on the ground, who are based in the countries they study, or that are part, they have in the study team people that are based in the countries they study. And so, one of the things we're particularly proud of in the special issue is having papers from scholars in Sub-Saharan Africa in particular, but also more widely in non-European, non-US countries who work showcased. And why is that so important is exactly because, it is actually, slightly more convincing to say you know the realities on the ground if actually you are on the ground. Now, so that's one thing. The other thing, and I think that's also relevant for a lot of what the papers we saw and possibly other work you're working on, is that ultimately as economists, so, some of you are possibly geospatial specialists, I know you are, some of us are economists. JDE is the Journal of Development Economics, so we're looking at economics, and so as economists, we want to understand mechanisms. We're interested in understanding human behavior and in how people, indeed, households, communities adapt or react to shocks, and so we need to be able to go beyond the black box. And of course, the Earth observation data doesn't give us that narrative story, right? It tells us what's happening. It gives us an observation of things that as we can observe them in terms of the result of a bunch of economic decision making, but we don't have the data on the economic decision making itself. And so in order to be able to go into the black box, we need to go beyond. And of course, I think some of the most exciting papers, therefore, including in the special issue, are the ones that can combine both the primary data collection and the Earth observation data. And going back to what David was saying, of course, that kind of, as always, as economists, we kind of want all, and we don't want the cheap solutions. But ultimately, there is going to be an argument for every specific case of whether we learn enough if we don't if we only have one source of data. And finally, and this is related to the kind of one, I think the challenge is and that maybe not so much for the special issue, but for this literature, is the political economy of this, right? Those of you who kind of invested in remote sensing data or in Earth observation kind of methodologies kind of say, okay, this is great, we have a new solution, we don't need this costly primary data collection anymore, we're going to show you how to do work differently. And so, David was talking about cost-effective research, and I fully agree we should cost-effective research, but that does not mean low-cost research. It's a very different thing, and that mistake gets done at all. I didn't say you made this mistake, to be clear, but I think some of you may be tempted to kind of oversell your work in a certain way because it looks like it's lower cost. No, partly it's not lower cost because you have all the salary and all the kind of, there is other types of costs other than the primary data collection, but partly also is the kind of without the ground truth data, without the mechanisms, etc., we only learn, but we both risk making mistakes and we learn only a fraction of what we could learn. Okay, so the special issue, I think, demonstrates what can be done in some of those spaces, and then so I encourage you, you'll see some of the papers here. We also encourage you to look at the full ensemble of papers. I think, so we want to see more of that work, including with work that does more on the measurement validation side, that cross-validates between different methods, but also, and that's the last point I'm going to say, is work that is very transparent about the remaining challenges. Right? And I think a lot of the kind of the editorial work in a certain way we've done is this kind of saying, yeah, it's fine, nothing is perfect, no research is perfect, but let's kind of collectively be open about the caveats, the weaknesses in having given paper, because that then allows to build on for the next steps ahead. And with that, I'll just kind of repeating, for those of you that are part of the special issue, I'm very excited that we will be able to put this together, and I'm looking forward to the event.
Thanks again, Karen and David. Appreciate those. Thanks. Yeah. Great. So thanks again for being here and contributing to this, what Karen was describing as a very multidisciplinary, interdisciplinary gathering. We've got economists, geospatial and remote sensing experts, policymakers, folks from all over the world. Really appreciate this coming together. We've brought you here under the banner of GeoField, which is our initiative supported by the Gates Foundation very graciously, and our partnership at AidData together with Dev Global and Mercy Corps. You'll see various members of our team over the next few days. And the goal of our initiative has been to focus on integrating climate sensitive agriculture, integrating Earth observation into impact evaluations of programs in this space. This was something we launched as an initiative about 3 years ago. David referenced we had kind of a kickoff convening here at the FAO about just under 3 years ago. And this event today is the culmination of a lot of that effort over the past 3 years. The whole initiative is really inspired by a sense of urgency. So it's not lost on anyone how warm it is, even in very early June in Rome and around the world. And climate change, I will not attempt to convince you that it's real and is happening now. And as a result, we need smarter programming and solutions now, right? We can't wait 5 or 10 more years to conduct a large-scale randomized trial and see its long-term effects. We need to be able to learn from programs that have already been carried out, right? We need to be able to reach back into the last 5 or 10 years of programs and understand what effects they've had and learn from them. So the learning that we need to be doing collectively has to happen faster. And we need new tools to be able to do that. We also, as Karen was saying, are faced with many limitations when we use what has traditionally been our impact evaluation toolbox. Again, that heavily relies on primary data collection. And resources being what they are, including new constraints to money for data collection, David was referencing, and the limitations of being able to send out field teams into many difficult places, the expense of doing it, all of those are real constraints that we face every day. And so what if we were able to relax those constraints by integrating new data sources and being able to learn in more locations around the world at larger scopes and faster? That was the inspiration for trying to integrate this data together. So our GeoField initiative has focused, really, I think our biggest contribution has been to try to build the body of knowledge on how to do this, how to integrate these two types of expertise together. Right? And we've done this by focusing on a bunch of different types of knowledge. Again, with this idea that different disciplines respond differently to different types of evidence presented in different formats with different resources behind them. So one of the main things we've done is our own research team, partly at AidData, partly by bringing in other folks from around the world, has worked on a set of use cases. So where we've integrated Earth observation into impact evaluations. And for the rest of the sessions today, we're going to present those use cases, 9 of those use cases to you today. I'll tell you that they are at varying stages of completion. So those challenges that Karen was referring to are very real, and we have felt them ourselves, and we will be as transparent as we can about them. Some of them are nicely polished and already published. Many of them are not. And we'll look for your suggestions and guidance on how we can get them to the finish line if one exists for them. Again, that learning is partly the contribution. So we never expected them all to go perfectly smoothly. In fact, we chose them partly based on the level of difficulty and challenge that they represented. So we'll present those to you for the rest of the day. We've tried to, in all of those cases, integrate partner organizations collaboratively. Again, partly because, as Karen was saying, we need a deep understanding of what the actual program logic was, what the program interventions consisted of, any ground data that was available, certainly administrative data on the programs that our remote sensing experts can then come alongside and complement. So in each of those cases, we'll try to tag team presentations by folks who have both of those types of expertise. Karen already referenced the Journal of Development Economics special issue. Tomorrow morning, we have 2 parallel sessions that will present papers from that special issue. Very excited about those. As Karen said, they represent a wide array of geographic context, contributor backgrounds, all sorts of neat diversity, I would say, in that special issue. We've also been laboring for the last 2.5 years on a new textbook. It's called GIE in Practice. In a few minutes, I'll invite my co-editors, Kunwar Singh and Claire Zanuso, up to tell you a little bit more about that. I'll just say that it's been a labor of love. As you can imagine, a textbook is not something that you do unless you are deeply committed in some core way to the principles of it. And many of you have contributed chapters to that, so it's an edited volume. We did not set out to write the textbook ourselves. We instead thought we could cajole many of you into giving us your time and effort, both in writing it and then reviewing it. So we really appreciate that. The textbook will be open access, and you'll hear again more about that in a little bit. But again, the goal was really to be able to give you not just fully completed projects, but also kind of how-to manuals, including exercises and data that you could learn a new approach to any one of these disciplines in. Another type of knowledge we wanted to tackle was partner organizations, in this case, our partners at Macours, understanding how ready they are to take on these kinds of impact evaluations that are Earth observation powered with their own data and programming. And so our partners at Macours completed this Are You GIE Ready assessment by really surveying their own staff and understanding what data they already had in-house that was geospatially referenced, that described the programs in enough detail to be able to evaluate them well, and produce this really nice assessment that's on our GeoField.org site. So I encourage you to check that out. As I said, it's really an effort to target partner organizations who are in the programming space. Mentioned this before, but a lot of the effort has also been to complement papers with data and tool sets. So on our geofield.org site, we already have a bunch of resources. Many of you suggested or contributed to those resources. Again, we appreciate that. And we're always excited about integrating more. So if you have suggestions or ideas, we'd love to have them. And then holding these kinds of events to bring folks together, both virtually and in person. Those have all been the different types of ways that we've tried to build this body of knowledge. Thanks again, Karen, for accepting the crazy idea that we try to do this. So when we initially proposed this JDE special issue, still remember trying to like type up the kind of basic idea behind it and doing a quick literature search to see, okay, what papers have already done this? And if I'm being honest, it was a pretty short like paragraph that I wrote that said there's like only a handful of papers that have done this. So the fact that the JD special issue itself has a dozen papers and that many of you are going to present others both in the textbook and through open submissions has been incredibly encouraging and really exciting. So let me just take a few minutes to dive a little bit deeper into some of the points that David and Karen just made. I tied their hands by saying you have 10 minutes, no slides, give us big ideas, because I figured I would get into the little bit of the gory details with you. So big themes, again, echoing some of the things you've already heard. I've been incredibly encouraged by what has felt like substantial growth. I don't want to say explosion because that feels like too grand, but really accelerating interest in using Earth observation together with the tools of causal inference to get at problems that we previously thought were intractable. This is happening not just among academics, but increasingly at many multilateral, bilateral, not-for-profit organizations across the space. So many of you here today represent organizations who are trying to do this in-house more and more, often by building multidisciplinary teams. So again, as David was saying, the ESA division that's helping to organize and host us has been partnering with lots of other parts of the FAO to do this in-house. Our partners at EFAD are doing this. You can see this list, and I've left off many of you as well, but your work here is really appreciated. Karen also mentioned this. One of my biggest pet peeves has been the constant need over the last 3 or 4 years to try to explain that no, we were not trying to replace surveys with satellites. Okay? That is not the goal, partly because, as you said, both data have deep biases. And as soon as we start talking to someone from a different discipline and getting under the hood a little bit, we realize that there is no way we're going to replace a 2-hour-long farmer survey with one sentinel or even a whole season's worth of sentinel imagery and say that those two things are the same. Right? And even more so, I think maybe the part that I didn't understand at the beginning was that these data are complementary in ways that actually mean that putting the two together is more than just the sum of their individual parts, right? They actually allow you to leverage new parts of that data that you didn't truly understand beforehand. And we'll get into, I think, a lot of that power as we get into the next couple of days. Another really important part is this interdisciplinarity. I mentioned before, there are people in this room whose training and expertise is entirely different than your own. And I encourage you to dive into that. It takes a lot of humility. We all have like our own, way of thinking. And as professors, let's be honest, we often like indoctrinate people that this is the way. And then you encounter someone from a different way and they've been told that theirs is the way, and we have to like work hard to not constantly micro-offend each other and be open to this like different language, even when we're saying the same thing. Kunwar and I still, after working together for a very long time, look at the same set of results, and I'm very upset because there's no stars, and Kunwar loves that the R² is very high. And so we have to just take this humility and interdisciplinarity seriously as we encounter this. But it also means that the way that we work together is going to look different. So the teams might be bigger, for example, than we're used to in some ways. And the mixture of expertise is going to be wider, including local participation in some cases, partner organization participation, a whole array of different composition types. And those are not required, but they're increasingly common, and we have to be kind of open to that idea. You guys are all committed to open science. I'm not gonna drone on about that. Just want to highlight for you some of the progress that I think we've been able to make as a community over the last few years. I went back to some of the comments that I made 3 years ago that were, I would say, like optimistic projections of where I hoped Earth observation would be able to help. At that point, again, as I did that original literature review, a lot of the work had been on using satellites to predict wheat and corn yields. Partly in like the United States, corn belt, where fields are huge and it's all corn, and the satellite data are really good, and you can do this reasonably well. And so the hope was really that obviously we could extend that to smaller fields in more diverse contexts with more middling satellite data coverage, but also that we could do more than just look at yields, that we could think about all sorts of practices in particular. So that includes the way that you prepare the land for planting, a lot of really good work on that, including from folks in the room, how you use the water resources that you're growing the crops with, both in terms of applying water through irrigation, but also in terms of how you harvest rainwater in difficult contexts, dry parts of the West Africa. We've just seen a whole slew of different practices that are now more directly observable, or at least like indirectly observable with better proxies just over the last few years. And this often is requiring higher and higher, I would say, spatial and/or temporal resolution data, but those are increasingly like in our wheelhouse. They're both available, and we kind of know how to grapple with them more positively. Karen mentioned this before, this idea that there's like trade-offs between the agricultural uses of land and some of the environmental spillovers or effects. These Earth observation data have actually been quite useful in being able to observe more than just what a farmer's survey might tell you is happening on the field. That's another kind of, I think, big area of potential contribution from Earth observation, partly because honestly, many farmers aren't going to entirely understand the mechanisms behind the environmental spillovers that happen. Right? Like the erosion effects of irrigation aren't necessarily well understood by people even who are doing the irrigating. But this idea that we can observe these in both fine detail and at a large enough scale to do ecology measures, this is really, I would say, where environmental science and the use of Earth observation is already very, very deep, and we can really lean into that as a community and say, how can we leverage everything that's being done already by this community? Again, lots of great work in the special issue that Karen mentioned on some of these. Sorry, you could see there's a lot of citations. I'm not going to call you out by name. You'll get your own chance to stand up here in one of the other rooms and present your work in detail. I mentioned before this idea that we really need to learn faster by going back to already completed work and seeing what its long-term effects have been. We can't wait for new programming now to launch for 10 years from now to see what its long-term effects are. And being able to overlay Earth observation over already completed projects at long time scales has been, I would say, one of the most encouraging parts of the use of Earth observation, in my view. In many cases, we're able to go back, again, over decades. Sometimes that's relying entirely on Landsat, and you have to have programs whose effects you can observe at a 30-meter scale, but, Sentinel has been around for 10 plus years now, right? And that gives us a long window to use. In some cases, we're also increasingly able to use high-resolution images from Vantor or Planet or other sources that, again, have been around for a while and give us pretty reasonable looks at baseline conditions for these. And both David and Karen mentioned this idea that many programs are designed to work primarily under a limited set, but of difficult environmental conditions. So drought conditions, or like these key time windows during which the program is meant to actually help. And sometimes when we commission a survey and design a survey ahead of time, you know, I've done this, like I'm hoping that there might be some part of my sample when I'm doing it now that might be experiencing a drought. I'm expecting there will, but you know, I obviously from a like human perspective, I'm hoping nobody does that. But if that happens, I won't be able to reliably measure with a survey what the benefits are of the program that I'm trying to evaluate. That we don't have to face quite those trade-offs in cases where satellite data are reasonably continuous time series, right? We can rely on using that to observe those key windows. Sometimes those are key windows over years, like between seasons, again, being able to see a drought versus no drought condition. Sometimes that's during key parts of the agricultural cycle. So you'll see a little bit later on, for example, irrigated rice in Bangladesh, where program focusing on alternate wetting and drying as a strategy to reduce water use. That's really observable only during the first few months of the season. So we have to have reliable looks through satellite data over those key months. And again, that's something that Earth observation is letting us do in ways that are more nuanced than a survey that comes only at the end of the season can really do. One thing I perhaps didn't quite appreciate, again, a couple of years ago that's been really eye-opening is that the higher frequency that's available through Earth observation data also actually lets us have more rigorous causal inference designs and be able to recover opportunities to do, again, rigorous causal inference, because it allows us to catch key windows during which only a part of the sample has been treated. And so that unlocks these staggered rollout designs that Karen was bemoaning, having probably seen like 10,000 submissions using these designs. And so we're just contributing the next 10,000 to them. But in many ways, these are really powerful tools to, again, recover learning from already completed projects. Right? Again, 10 years ago, we really always bemoaned the idea that you would just get like a before and after and a pre-post kind of design, and maybe you can go out and find some comparison group somewhere that was never treated. And increasingly, what we can now do is to look like at a yet to be treated comparison group that we can identify reliably and have multiple looks at those staggered rollouts. In some cases, it's not just this intermediate window during which a part of our sample has been treated that we're recovering, but the longer time series and the more continuous time series unlocks tools like synthetic controls that let us more reliably estimate comparison groups, even in those kinds of cases. David and Karen and I did not coordinate on this talk, as they will attest. I gave them very little guidance. And so the fact that many of our comments are actually consistent is, again, I would say like a good sign for the field as a whole. These tools also allow us to recover learning opportunities in some of the most important places. Conflict-affected contexts where ground data are not easily attainable, and where some of the program impacts might be largest and most valuable. These are really important places to learn. And Earth observation in these contexts, again, can't substitute entirely for what you could do with ground surveys, but it can get us really important answers. Again, in contexts where that's just not attainable, often, again, over long time series. So in many of these projects, okay, well, Klaus's excellent work in Ukraine is very, very recent, but some of the other work that we've done has been, again, going back to places where that conflict is 5 or 10 years old and being able to learn in those places as well. We knew that there would be new challenges. We didn't know, again, 2.5, 3 years ago what those new challenges would be, and so I really appreciate several JDE special issue chapters, some of which you'll see, that pointed out those new challenges. For example, you think you're getting rainfall or precipitation data from a satellite, and then several of our contributors here will tell you those data are wildly different, and they also not just are wildly different, but you'll get very different impact estimates if you use them differently. So you have to think more deeply about that. Also, kind of this integration of ground or survey data together with Earth observation data and how to optimally leverage those two things is not simple, right? It's not just a matter of saying, okay, what sample do I need for training and validation of my AI-powered or machine learning-powered classification algorithm? Okay, I need 200 fields. That's all the ground survey data I need. Done. Actually, there's a lot more that goes into this. So really appreciate kind of deeper thinking that's gone on about how to best combine these. Okay. That was kind of 3 years ago, projecting into the future and what's happened. If we now pan further into the future, where are we going? I will give you my 2 cents. These are maybe less than 2 cents worth, but these are the parts that I'm most excited about. I mentioned before this idea of learning faster and also learning about more than yields. So being able to observe kind of the most proximate measures of uptake or adoption of new practices that are being promoted, partly to deal with climate change, but also just more generally. That, again, takes higher resolution, typically higher temporal frequency data, but those are increasingly available. And being able to pin down, again, when farmers are adopting a new sustainable crop variety or a new type of planting as something that I think is still coming. A lot of the data that we've used is public access, and yet incredibly inaccessible to most people in this world. And so figuring out, we're talking Google Earth Engine is amazing. Almost nobody is going to use it. That's outside of a relatively small set of folks that's going to use it in these kind of impact evaluation contexts yet. So finding good ways to democratize that data, in many cases, all the way back down to the farmers whose program, the programs are working with. That includes ways to use these in digital advisory, like agricultural extension apps, but also to use them to actually learn about the impacts themselves. The geospatial experts in this room will tell you a lot more about the awesome new sensors that are now available, including hyperspectral and NISAR and all sorts of ways to get a gazillion bands out of every satellite. Those are incredibly powerful. And again, as we think about being able to observe finer practices, those are going to be increasingly useful to us. Not just finer practices, so not just being able to see a way a farmer is planting one row of crops, but also to be able to understand the way an entire economy is now shifted as a result of these. Because as Karen was mentioned, while we are studying individual programs, those are existing in an entire broader economy scale. So thinking about leveraging geospatial data to understand the mechanisms through which general equilibrium effects happen, through which market access is shaping how the response is occurring to a particular program, those kind of geospatial tools are increasingly kind of integrated. And then I would say the one area that we really hoped we'd make more progress on, there have been many intervening events in the past 3 years that have, I would say, limited this, but a deeper understanding of gender equity. When I was originally thinking about this point, I thought, even our most best powered, best designed surveys are almost never powered for subsample analysis by gender. We're already almost always stretching the dollars to get the biggest sample we can to measure our noisy outcomes. And so, like in many cases, to double the size of that so we could reliably tell, right, if a female-headed household is experiencing the same impacts as the rest of our sample, that almost never happens in surveys. So the idea, originally was, well, what if your sample was much larger because you could use satellite data to cover more of the country? And what you would need is a reliable georeference data set that indicated where female farmers were and what program they had been exposed to. And I would say that still is a promise that I think exists out there, but I've yet to see it like leveraged at scale in a real program. So that's maybe an encouragement and a challenge to all of you to think about doing that more. Okay. I'm going to invite my co-editors, Kunwar Singh and Claire Zanuso, up for just a minute to tell you a little bit more about this textbook. Claire, Kunwar.
Well, thanks, Ariel, and good morning, everyone. It feels like just yesterday, and we were here at FAO, in fact, in the same room during the first GeoField convening in 2023. And it's great to be back here again, and awesome to see so many familiar faces in person, rather than being in my second floor office and virtually Zooming and talking to everybody. So while I was talking to many of you, one thing struck to me is that many of how many contributors to the book are here in the room. Frankly, you are still here. That suggests that we did not overwhelm you completely. So that tells a lot. On a serious note, thank you for being awesome contributors, and this has been a collaborative effort, and I have to say thank you to all the authors, co-authors, on behalf of our editing team. And our plan was to launch this book at this convening, but after multiple extensions, finally we submitted on May 25th to the publisher. So there are a few facts about the book that I would like to share with you. So based on the publisher's communication with the publisher, this book should be published between mid-September to mid-August. And Claire will talk more about how it will be shared with the community. But the fact is that there are 32 chapters distributed in 3 different major sections, like foundations of geospatial impact evaluation, method for spatial causal inference, and applied use cases. There are total 13 use cases, and you will see distributed nicely across this global map. And they certainly represent the need where it is more applicable, more effective. And out of those 13 use cases, there are those distributed in 3 specific areas. The first one is environment and natural resources. Second one is agriculture and food system. And the third one is health, infrastructure, and mobility. There are exactly 80 contributors, including 3 of us as a co-editor. Means highest contribution is from 9, means author and co-authorship, up all the way up to like 1. And you will be surprised to know that we have almost 250 figures across the book. And I also want to, these are the big statistics, a lot of things Claire will share with you. But I also want to take a moment. I want to thank you, all the people who has helped us review the chapters, served as an external reviewer, and also those, some of them, they are not here. Few, like Sarah Saidi and Incheon, they are here. They helped us to move this book to this point. And I think we have done a great job. I think in next few weeks, you will hear from the publisher. That would be the second last step before it will go into final publishing mode. So thank you for all being awesome contributors.
Thank you, Kunwar, Ariel. So yes, 2.5 years ago, same place, we started with a shared conviction. As you mentioned, different background, different mindset, and a blank document. So today we have 32 chapters, 80 contributors, and a book. So I want to take a moment myself to thank you both, and every contributors and reviewers in this room for your commitment, your patience, and your trust on this. I hope you will love the results enough to share it widely when it comes out. Now the cover. So we went green, bold, spatial, unmistakably geospatial. You may recognize some of the country names or outlines. So they are the geographies behind the use cases in this book. And if you look closely, there are coordinates of the cover too. I will leave it to you to figure out where they point and consider it one of our last small invitation to stay curious. So the book will be in open access. We mentioned it several times, but it was really important for all of us, so that everything you have contributed can reach researchers, practitioners, students, decision makers across the world, including where access to academic resources is most limited. So we are also exploring now a French translation to extend its reach into Francophone research practitioners and policy communities where we think that English could still be a difficulty for them. But a textbook, it's still one vector. Ariel, you mentioned other breaks on the Learning Hub. Together with the European Space Agency and AidData, French research network, including the French Space Agency and the Institut de Recherche pour le Développement, we are developing a MOOC, a massive open online course aimed at decision makers to help them understand the value of GeoAI, but also the limits, and feel confident championing its use with other type of data in their teams, in their projects, in their public policies. Not only for impact evaluation, but also for targeting, decision-making, about the interventions that matter the most. So if any of this resonates, you can see we will have a dive deeper kind of toolbox where we can link to the many existing community, starting with GeoField, other of your contribution, the book, the MapMe community, they are here, please talk to them. So if any of this resonates, if you have ideas, feedback, or simply want to know more about it, about this way forward for the book, because the book will be disseminated with this MOOC and all the events that will be organized around, come and find us. We have a dedicated session Wednesday, 9 a.m., Philippines room, and we would love to hear from you. Thank you.